What is a moonquake? Earth's moon might appear to be dead calm and still on the outside, but below the surface, the moon is an active, vibrating body. We know this because humans have caused moonquakes ourselves with the Apollo missions, and the remains of that technology are still causing tremors on the moon as we speak. On November 19, 1969, the Apollo 12 mission commanded by Pete Conrad and Al Bean landed on the surface of the moon in a region known as the Ocean of Storms. Part of their mission was to deploy a payload known as the Apollo Lunar Surface Experiment Package, a collection of scientific instruments that included a remote seismic monitoring station, the kind of device that we would typically use to detect an earthquake. After completing their moonwalk and returning to the command module, Apollo 12 released their lunar ascent stage on a trajectory back to the moon's surface. They purposefully crashed the vehicle into the moon. It impacted the surface 40 miles away from the landing site with the force of about 1 ton of TNT. The seismic monitoring station was then able to measure the resulting shockwave from that impact. It took 8 minutes for the moonquake to build up and reach its peak, and then another hour for the tremor to fully dissipate. A similar event happened on Apollo 13. They never landed on the moon due to a technical failure en route, but one thing that Apollo 13 did accomplish was generating a massive moonquake. As part of their mission profile, the third stage of the Saturn V rocket, known as the S-4B, would be deployed on a crash course for the moon. The S-4B was a hydrogen propulsion stage that consisted of 2 large fuel tanks and a J-2 rocket engine, much larger and heavier than the lunar ascent vehicle. So, when this thing hit the moon, it generated the force of 11.5 tons of TNT, creating shockwaves 30 times greater and lasting 4 times longer than the Apollo 12 impact. In both of these experiments, the vibrations recorded by the remote seismic monitoring station lasted much longer than scientists had expected, and this observation led NASA officials to comment that the moon, quote, rang like a bell. Those particular words would go on to birth one of the more fringe conspiracy theories out there, known as the hollow moon. The idea is that since the moon rang like a bell, and bells are hollow, then the moon must therefore also be hollow. The generally agreed-upon explanation for the hollow moon is that we are actually being orbited by an ancient alien spaceship. So, first of all, an object does not need to be hollow in order to vibrate or even to ring. Case in point, the glockenspiel, which uses solid metal bars to create sustaining bell-like tones, or even its more primitive sister instrument, the xylophone, which creates ringing musical notes from blocks of wood. And, second off, the moon isn't hollow. If we think about the surface of the Earth, it's covered in a lot of water. The more moisture there is present in the surface materials, the less dense their structure will be. This damp material works like a sponge to absorb and deaden the vibrations created by an earthquake. It helps to keep the most severe effect localized to one area. If we think about the surface of the moon, it is totally dry. No moisture exists on the moon. The entire crust of the moon is one continuous, cold and rigid structure. So even if a moonquake is less intense than an earthquake, there is nothing to deaden the vibrations on the moon. They just continue to move back and forth through the body of the moon like a ringing bell until the stone eventually stops them. And this, unfortunately, is something that we are going to have to be considerate of as we move forward with the eventual settlement and colonization of the moon. We know that mining and long-term construction on the moon is an eventual goal of NASA's Artemis program. We know that China and their allies also want to establish a permanent base on the moon. What we don't know is how this massive increase in surface activity is going to affect the environment of the moon. We know that earthquakes are caused by the movement of tectonic plates that make up the surface of the Earth, but the moon does not have tectonic plates. The surface is all one continuous shell. So, what causes moonquakes? Well, one known variety of lunar activity is the emergent thermal quake. This is the easiest one to understand because we know that each half of the moon will experience 14 days of continuous sunlight, followed by 14 days of continuous darkness, and since the moon has no atmosphere to insulate the surface and maintain a consistent temperature, the surface can range from positive 250 degrees Fahrenheit during the daylight periods to negative 208 Fahrenheit during the nighttime periods. And just like any other solid material that is exposed to these drastic temperature swings, the surface of the moon will actually expand and contract as it moves from day to night. This movement causes significant vibrations to travel through the surface of the moon. Another common seismic activity on the moon is the tidal moonquake. On Earth, we experience the physical effect of the moon's gravity in the rising and falling of the ocean tides. By the same measure, the gravity of the Earth will also have an effect on the surface of the moon, pulling and stretching the surface material. This will also cause some residual seismic activity. And then, of course, the moon also experiences a pretty high frequency of natural impacts. In addition to humans throwing chunks of spaceships at it, the moon gets hit by asteroids of varying sizes, all the way from micrometeorites to metal boulders, each one leaving behind a seismic footprint. However, in 2023, researchers at the California Institute of Technology found a way to extract more detail from the lunar seismic profiling experiment data. They used artificial intelligence and machine learning algorithms to fill in the missing pieces of the seismic recordings. This AI upscaling gave the researchers enough detail to begin separating naturally occurring moonquakes from external influences. One of the more amazing discoveries was that the Apollo 17 lunar lander, which was left behind only around 100 meters from the seismic measuring equipment, is actually causing moonquakes itself. So what's been happening is that the lander has been traveling through the lunar day and night cycle for years. And as the temperatures swing from one extreme to the other, the metal structure has been expanding and contracting. That movement of the metal over the ground was enough to cause vibrations that traveled through the surface and reached the monitoring equipment. Now, this is an incredibly subtle tremor. If you were standing on the moon next to the lander, you wouldn't actively notice the vibration. But the fact that these micro moonquakes were present enough to be extracted from 50-year-old recording data just reinforces the fact that the moon's surface is a very strong conductor of vibrations, even very tiny ones. Then what do we think that a mining operation is going to do? Or the frequent landing and takeoff of a giant vehicle like the SpaceX Starship? We are going to have to accept the fact that a colonized moon will end up going into a constant state of seismic activity, a permanent moonquake, in addition to all of the naturally occurring moonquakes. So, just one of the many obstacles that humanity will need to overcome on a very long and difficult journey to becoming a multiplanetary civilization.